Hey guys, time for another chemistry problem. I would like to write the synthesis reaction for iron 3 oxide. Now, why is this 3 necessary? Why do we need that? If you look at your periodic table, you'll see that actually iron is one of those metals in the middle of the table that can have more than one possible charge. It can either have a +2 charge or a +3 charge. So this 3 here has no relation to how many of the ions are going to be in the in this particle. Um, it helps to determine it, but it does not mean by itself that there are 3 irons in this thing. No, that's not what it means. It means that when you put it together with the oxide, the iron has a +3 charge, and then you balance it based on that. Let's get down to business. A synthesis reaction involves putting pieces together so that you make something new. Iron oxide is going to be made of iron and guess what? Right, oxygen. So iron plus oxygen. And this is going to give iron 3 oxide. Now, in order to figure out what goes here and here, like I need to know what sort of subscripts I'm going to put there. I'm going to put, I'll do some scratch work down the bottom here. I'll say Fe is going to be 3 plus, and oxygen, remember that when it's an oxide ion, yes, this is ionic, oxygen, when it's oxide as an ion, it has a -2 charge, and it is all by itself. It does not, no, it does not have a 2 there. Nope, that is not there. It's just by itself, just 1, and it has a 2 minus charge. The thing that tells you how to write an ionic formula is how those charges balance out. 3 and 2 can meet at 6, right? That's if you have 2 of these. That gives you a total charge of +6. And if I have 3 of these, that gives me a total charge of -6. And this is the magic point where they cancel out. So this tells me that I must have 2 of the irons and 3 of the oxygens. That tells me what to put over here. I know there's going to be 2 irons and 3 oxygens. Okay? Notice how I wrote these with a little bit of spacing. There's some spacing on each side of all of these. Like I didn't write this right up against the arrow. That's because I know that I am going to have to balance this equation as well. Oh yeah, we're not done yet. We have to balance it. Balancing means that you make sure that there's the same number of each type of atom on the left and on the right. So what you can do here is adjust each one individually, like this. I know that iron right now has 1 on the left and 2 on the right. Well, I don't want that. That's not balanced, because right now what I'm saying is that somehow I start out with 1 atom of iron and then I end up with 2, like another one has just magically appeared out of nowhere. That doesn't happen. So I really must have started with 2 atoms of iron. Okay, so now this is fixed, right? Well, the iron is, but the oxygen isn't. Now, you can address this a couple of different ways. You can multiply the oxygen by a fraction in the meantime. Like, how do I turn this 2 into this 3? Well, there are some classes that will teach you to do whole numbers no matter what. I'm going to say that although your result needs to be whole numbers, it's okay if you do by fractions in the meantime. We'll see what I mean by that in just a second. So what if I times this by 3 halves? Okay, well, 3 halves times 2 is 3, which now matches with this. So I've fixed it, but it's very common in chemical reactions to require that everything be whole numbers. So In order to fix this and cause there to be no fractions at all, I'm going to times everything by, and guess what's going to make that fraction go away? Well, if you multiply by the bottom of a fraction, it goes away, right? So times everything by 2, and that means that what used to be a 2 is going to become a 4. What used to be 3 over 2 is going to become a 3. And what used to be a 1, like there used to be a 1 here, you don't write it just like in algebra. What used to be a 1 is going to become a 2. Now everything is whole numbers and it's balanced. You have 4 irons on the left and 4 irons on the right. 2 times 2 is 4 copies of iron. You have 6 oxygens. 3 times 2 is 6. And 6 oxygen over here. 2 times 3 is 6. And those are the only ingredients we're worried about here because they're the only things involved in the reaction. So now this is balanced. We could ask more interesting stuff about it, but we'll leave that for another video. Listen, if you found this helpful and you would like to set up a session to talk about your assignments, feel free to give me a text or call me at 617-966-3198, or you can always visit my website at sntutoring.com if you'd like to set up a session to talk about your assignments. Thanks, guys.